Okay, so like Janice said, I'm the director of Global Primary Products, IPS Systems, Manufacturing, and Automation. So lots of words, but when you're, like somebody was saying earlier this week, when you're in a big company, you've got to figure out which part of that company you're in. So that's what's going on with that. Alcoa, a lot of you know about it, but it's a fully integrated, vertically integrated aluminum producer. We do everything from dig it out of the ground, we smelt it, we form it, we mold it, we extrude it, we roll it, and eventually we even turn into value-added products and put on the market for aerospace and in all the markets you can see there. So a lot of exciting things come out of the company. And latest update, the 1888 founding, that hasn't changed in a while, but we're at 59,000 employees, 30 countries, and in 2014 we hit 23.9 billion in sales. So I only put that up there because it does help define the journey, because you're not trying to convince 5 people or 10 people. You're going after a pretty large company with a lot of history. So when you take on the culture changes that I'll talk about at the end, it can be pretty significant. Okay, big data. Janice said big data, I'm going to mess up the quote, but it basically is useless without blah, blah, blah. And I totally agree with that. In a smelter, or in a series of smelter, big data is all about scale as well. Before we started down our smart manufacturing journey, we were a company of acquisition, so we had this control system, that control system, everything from SneakerNet to FTP back in the day, and lots of machines not on the network. So as we brought in our smart manufacturing, which I'll give the one commercial for, that's based on the OSI Pi suite, we had a lot of information silos both within the plant, and we also had them across the plants. And when you said to people, oh, what's going on in your pot room operations, you would have a version of the truth on the floor, a version of the truth in the that plant manager's office, then another version of truth in the at the business unit level, and various combination of those as you went through the hierarchy. Each of those silos and each of those misinformations and each of those gaps in the truth cost us money, and we've identified that now, and we've decided to go after it. So what we've really done now is we've gone into our 18 smelters. We finished this in 12 of them, and we're doing 2 more this year, and the other ones may have a business case where we don't actually go in and do them with the current economy, but so we've made really good progress. But we've got about 1 million tags now in each one of these smelters, and we are rolling those up now. And I'm going to try to show you today, with any luck, how we turn that into actionable information in the moment and get people to the right place at the right time to make the right decision. So one of the key enablers is the data model. The consistency of the context of the data as you go across these smelters is an absolute must. If not, you may be able to brute force your initial implementation, but when you start to evolve it, change it, get into the continuous change and the continuous growth, when you decide, oh, I need to change how this KPI is calculated, if you don't have a data model to support you, forget about it, because you can't roll it out. So with a strong data model and a strong method for keeping that data model consistent across all your historians, you end up with something you can sustain and keep moving. Some people ask me, is it really being used? So I did go ahead and throw up some pictures here. This is 4 different plants where people are using the large screen, standing in front of them, making decisions. Well, nobody's making a decision down there, but they'll be there in a half hour to make their decisions. And so it is being used continuously. And the other point of the screen is, if you look at those, you see all kinds of data and all kinds of charts. So when we talk about the various forms of the smart manufacturing revolution, and you get into, is analytics more important or visualization more important, I would say you can't break them apart. Because if you don't find a way to do the right analytics, then you're just throwing the same data everybody's always had, you're just putting it into a pretty format. So hopefully we'll see a little bit of that too. The problem we were trying to solve, once we got going down our deployment road, which we started with, in 2010, we had none of this in place, and we started with a pilot, we started with an enterprise agreement, and then we rolled this out. And as we got to, where we had the visualization in front of people, it became very apparent very quickly that we had to do something different, because we were just showing the same data to people on the pretty graphs, and we had to find a way to get it actionable. So we said, okay, one thing we're going to do, let's use our in control and capable routes, and let's identify a project that says we're going to go after variability. So, with easy statistics, you say, okay, if we could just get rid of all the pot days that are running below our normal current efficiency, we could run better and make more money. That's easy to say, but now what are you going to do about it? Because you got to not only know which pots are causing you trouble, you got to know which pots may cause you trouble tomorrow, and you've got to know what action to take on those pots to put them back into your normal distribution. So easy to say for a statistician, now you got to figure out what to do. And Mohammed, you gave a great example of your decision tree and how you work your way down to the root cause. I'm not going to show the decision tree and all that, but I'm going to show on our side the front end of how we get that to the operations and get it out there. The key on this screen is really down toward the bottom, because when you say, all these things are important, but down at the bottom you talk about getting into better control. And people in different things all week have been talking about, do you close the loop or not? Do you make this about real control? No, it's not about real-time control. We're doing this, but we're going to export the proper analytics, the proper KPIs, the proper metrics to modeling systems and everything else, and then we're going to find a way to bring that back in and drive the decisions. So when we talk about closing the loop, we're not going to close it in real time at an actuator or a PID, something like that. We're going to close it with, since we're in a long-term continuous system, we're going to close that loop with an adjustment to our tuning method or something. So we will close it, but it's not going to be an immediate. And we really have a firm line in our sand, but in our visualization and our smart manufacturing layer, we are not going to push down real-time control. The other thing the model had to do is it can't just say, oh, let's do it the easy way, because we've been doing that forever. The graphic is, I think, the best. In our world, it's easy to stand up here in the middle of this stage and never worry about falling off, but the money's out here. I can get your attention better if I'm out here on my toes looking at you, but I'm really too much of a coward, so I'm going to back up here. But in the optimization of a process, the money's out there on the edge, and you don't want to fall off, because if you fall off, it's going to cost you way more money to get stable and get back up on that hill and start trying again. So you want to go to the edge and get as much money as you can without falling off. So as we get into our more advanced modeling, which we've got projects going on now, I'm going to briefly mention, it's all about that. And so we'll talk about that a little bit. All right, now wish me luck, because we're going to try to go live, and we'll see if it works. Okay, so we're now live on one of our systems. So this is our asset health module, and we have created that internally. And what that's doing behind the scenes is going through the decision trees that, like Mohammed was talking about, and it's doing some very basic analytics to say, okay, not doing single variable analysis anymore, but doing clustering, and then coming up and saying, well, this variable and this variable, or this variable, and this variable, they're over here. So they drive, the combination of those and the calculations drive the pots, which are listed in the columns in the center, drive those onto the list that say, these pots need to have their feed control adjusted today, okay? And if you don't adjust the parameters for their feed control, they're going to either be very unhealthy tomorrow, or we've already got advanced information that says they're getting unhealthy now. So the So the pot line where this is running has 750 pots. So the people don't always have time to go out and do all 750 pots every day, variable by variable, line by line. So the analytics behind this, which runs all the time, comes up and says, okay, if you get time, go work on these 10 pots in each of the lines. They're your 10 worst actors. They're costing you the most money. So go fix those and you'll have a prayer. And as you click on those, you can get the individual parameters. You know, as you click on the pots, it brings up the latest value of these key elements. And don't worry too much about those because, as I said earlier, the traditional numbers you used to measure aren't the ones you measure anymore and aren't the ones that matter. So if we say anode effects here, anybody who's ever done pot operation may think they know what that is, but that's most likely a massaged element that we've done some analytics to turn it into a value that we know if that variable's going high, we've got issues. So if we want to go look at that, you know, in this case it's the bath ratio that's taking us out. So we can click and maybe get something to happen. Yeah, good, wake up. And so we can get a nice chart of that. And if we go back and we click on the other one that's out of whack, the noise, it'll put those two graphs on top of each other with any luck. And we can start to see, you know, this is a 30-day view, but it comes back and gives us the ability right away to zoom in. But once you've gotten to this point, the analytics behind it have already ensured you that these are, in this case, the 30 pots. The others are off the screen due to resolution. These are the 30 pots that you need to work on the most to go fix your life and make your life better tomorrow. So once you have that going, there's different lists with different clicks and with different default configurations in the different break rooms or the supervisor rooms. So the list of pots that are coming to the top in the operator break room, that's the list of pots that the operator has to go to right now. I mean, the next time you come off break, go to this pot because it's the one hurting you the most. And after you fix that one, go to this one. The list that's coming up in the supervisor room is the list of pots that something's not exactly right and they don't know, so you need somebody who's got a little more training to go look at that pot and take a look under it. And then the list that comes up for the technician who does the day-to-day tuning, it comes up and says, well, okay, great, we're going to adjust the feed control parameters of these pots. So you already know when you look at your screen which problems you're working on and what's the context and what you're going to go fix. So that's for the real time in the moment. The engine behind that's running, I think we run the engine about once a minute, and you know, there's everything from 30-second aggregates to 3-hour aggregates to 6-hour aggregates to dailies that are behind there in that secret sauce calculation for, you know, how to sort the right pots to the top. So, and that's, we refer to that as this is what we've always done, this is what we've always taught people to do with our best practice, but we really couldn't make sure it was done every day because you can give people this 3-page SOP for going to do this, but does it really happen? You really don't know. And do they use the same thought process? Well, we've taken that part out of it and we've given them the list to go attack. So once you've got the So once you've got the on the floor part, now what do you do with it? Remember, we were also going after a single version of the truth. So we decided we needed a business unit-wide dashboard where we could take all the data that's coming at us from those KPIs and we could try to roll those up, because we for years have had a best practices center of excellence, technology center of excellence that works with the plants on increasing the plant stability, trying to avoid excursions, trying to, just trying to smooth things out. Because I didn't say this earlier, but pot room operation is like steering an aircraft carrier. You've got to make a change really a little bit at a time, and you've got to know where you're headed. And if the process makes that same change, if you don't detect it early, by the time you're, outside the dead bands, it's too late. You're going to spend the next 10 days out of the dead bands, as you try to bring that process back in. So it's a very slow process. So a lot of our activity is trying to not let it get that far out of the ditches. So as we roll this up, the highest level roll up, we come up with a bi-plant or bisector. And if we go into the bi-plant, we quickly go in and look at all of our plants. And in the column that's here, we've actually rolled up the stability metric for that plant and taken somewhere on the order of the 10,000 different variables that are out there for each pot, and we've converted those into, we think the stability of that pot line is a 82% or a 68 or a 100. And those, right now, we've got a score that we're calculating in the background with all of our analytics, and then we've got a score that our COE team that looks at this every week, we come in and look at that with the additional information you can get by phone calls to the plant and everything else. And we'll sometimes, and we're developing this analytic now to start matching more and more. So all the fancy numbers calculate, okay, it's a 72, but then as the team talks, they'll say, oh, we got extra information from the maintenance guy at the plant, and we had to fix this. So what we're going to do is we're going to say it's really green, even though it might be red or yellow on the chart, or vice versa. But we're using that to tune our metric. So, when you see 100, of course that plant's not perfect, but that one there's nothing we thought we could work on that day. So those are the list of our plants down the side, and you can go in and look at the individual parameters, but if I bring up that screen, then I gotta shoot you all because you got secret data in there. And I was told that was frowned upon. So if we go in more at the pot room, at the KPI level, you can see again, just because it says DCKW, now that is our energy consumption, and you can see that number, and so, energy consumption per kilogram, that's one of the things I'm not going to show. But the other things down here, like pots greater than 980, that may be that exactly, or it might be that with, some statistical tweaks going on in the background. Because you've got to make the data valid. So the data validation and calculations are going in behind that. But we're going to look at that one. And so with this click, we can go to our instance. We're bringing now in the data from the last 3 months from the however many plants we have up there now, putting it on the graph. The red, yellow, green agreements have been made at a business unit wide level. And basically for each of these plants, if the green limit means that plant's going to be able to make their plan if they run that way, and we don't need to overreact. And then in this case it's mostly a technical parameter, so we know that if we're doing okay, we're in the green, we know we're probably all right, and we can also watch the trending. Are we using SPC rules? Yes and no. In a lot of cases we are still working through our legacy on the fact that we think we know better than Deming how to calculate those limits. Well, of course we don't, but it's a culture change. But we do have the limits. They're consistent, and they are the people on the shop floor and the people in the boardroom know the limits, and they know how the values are calculated, and so they're going by these same numbers. If I click on one of those, I can drill in, see the full screen, and I can see exactly where the data was. This is another interesting example. We have this data available every day. We've got daily data for the temperatures because we measure the temperatures every day. But historically, people want to look at that weekly. Okay, so we give them a weekly aggregate. Eventually, they'll come around and they'll realize more is better. Also on here's an example. They did have an excursion at this plant, and the process engineer, who happens to be me for this demo, if you read real closely, went in and put, the extra cold temperature caused the equipment in the GTC to freeze up, and we had to go, we had to thaw it out with some heaters, and then we ordered some construction work to get insulation installed so it doesn't happen again. So this was one of our plants in Quebec, and we actually froze up some things that shouldn't have frozen, but when it's 35 below, it happens. And we tracked the follow-up here, oops, The green flag in the bottom left says the follow-up happened, and we did close the root cause. And we're on the beginning of that journey. We've been doing that with our manual systems for a long time, but it's been cumbersome, and now by putting it on the electrical system, we're getting more and more energy going into the real effort instead of chasing the paper. So that's really what we're trying to do. So when we're in this view that's expanded, we also, people like to look at the big pictures. So we put a red arrow and a white arrow. If you go a white arrow, you'll just go to the next KPI, no problem. If you go to the red one, it's going to take you to the next one on that series that's having a problem. So you can just very quickly walk through the red plants in this case, and you can leave the ones that are all running fine alone. So our hope there is to drive a single version of the truth. Now, if I go back to that level, this consensus score I'm talking about, I'm really proud of. And again, we're on the verge of this. We've been doing it now for we've been calculating the data for apparently never. We've been calculating the data with spreadsheets and manual systems for quite some time. And since, let's see, we're in February now. I think it was October 1st we started using these screens exclusively for our weekly stability reviews with our COE. And what these metrics are, and I know they're too small for you to see, and part of that's intentional, but this is that single analytic that we're calculating that says this is the stability of the plant based on the leading indicators. So as you look through there, some of these plants have been running very consistently in the green. Some of them have been really struggling, and some of them, you may wonder why they don't have data. And like I said, we are on a journey. So still tweaking the metric, but it is moving, and we're seeing reasonable results in that space. And that's the actual raw score. And then since we're here, we'll go into that consensus score. Like I said, the team meets every week, and in that weekly meeting, we review the data and we say, all right, based on all of our input, it's green, yellow, or red, or high red. And that's what we plot in on this chart. And so we're correlating, kind of this model to the real-time model. And then ultimately, when I say we roll up the 15 million or 15 to 20 million tags into one, this is if you take all the stability of all the plants, aggregate it by the ton, aggregate it by the power of the plant and how much that plant can get us into trouble. This is when it works to all of our satisfaction. We're not there yet. This is going to be whether our BU president can go to sleep at night and be happy and not have to worry about it. Okay, so the overall target is to truly get it up there, because if we go back to where they were before, the number of charts that you look at can be just overwhelming. Okay. So I had slides in here just in case that didn't work, but it worked all right, so we will go there. On the benefit side, very conservatively, the reduced variability is worth $10 million a year across our business, and that's actually taking every number that we went out and calculated and divided by 3, and then probably taking off some more safety factors, because in our company, if you put down a number you're going to go make it, you better make it. So we've got a $10 million bogey on that for, we don't have to make it in 15, but by end of 2016, we've got to be tracking that in our value tracking system. The predicting and reacting to excursions, when we have a true excursion, it's somewhere between $5 and $40 million. And when you go back after the fact and measure what it costs to, let that line get too cold and just go crazy, or if your alumina was coming in and it really wasn't what you thought it was, so the pot just gets totally messed up. I mean, it literally can cost that kind of money. The standardization and the codification of best practices, that is so important to the sustainable thing. You know, we've been talking about the value-added people and how we've got a lot of rollover and going from the, you know, the gray-haired people and the baby boomers to the millennials. If we can codify these best practices into these screens and all these calculations, so when the person sits down, he or she knows they're looking for, I know I'm only looking at the hot pots, and I'm only looking at the hot pots that have this, this, and this also, so that tells me I need to go do this. We think that's a way to sustain our execution. And then the transparency we're getting, that's another whole discussion, and maybe we'll have time for it in the panel, but when you start talking about the exact same parameter being measured on the floor and through an aggregation model rolling up to the plant, rolling up to the business, and even getting beyond that, and everybody having to buy into those calculations and how those numbers come together, you've got something powerful now. And no one argues about it anymore once you get to that point. Now, there's a lot of scars on my back from the arguments we've had up until now. Okay, and any of you who've tried to do this know it's not easy, and we're not finished yet, but it is quite a, when you get there, it's very enabling. And then on lessons learned, if you got a business unit problem, you probably need to attack it at the business unit level, trying to go at it one plant at a time, or 500 data points at a time, or something like that. You're not going to get there. And if you wait for perfect, don't even start, you've got to go. You got to put something out there, you got to get it in front of people, and you got to let people start to gain some credibility. But you've got to put a change management system in place so you know what you're doing. And that sounds conflicting, but you've got to do it. Technically, you know, the whole infrastructure, the guys this morning talked about how complicated that was and showed you slide after slide of all these architectural drawings with the security and this and that. Well, I'm sitting here in a conference room in a hotel in Orlando, and I'm using our real life system. I believe it's secure. It may not be, but and we hope we don't find out today. But we have followed a lot of the basic rules. We are behind firewalls. We have the right abstraction, and we aren't doing control. So when you put all that together, maybe it can come together and be all right. To do that part is challenging enough. And then when you bring on the business culture change to use this kind of data and make this kind of data valuable, that's when you really get and you start to see the value. So, you know, Janice talked about, you know, big data is useless unless you put it in context, and it's really useless unless you make money with it, okay? And that's really where we are at this point. And we are very religiously tracking our value add with this, and that's how we keep the ball rolling. Last note, by my experience, just because we've got a lot of plants even within our great organization, I would say there are organizations out there that aren't ready for this. And if you're not willing to share, you know, how to get where you're going and the difference between, you know, why is this one when it's just 0.1 below the line, you know, why is it costing this? If you're not willing to share that and talk about it, you may not want to go on this journey of transparency, because as you expose it and you enable people and you empower people with that information, they're going to ask you questions. And that, by the way, drives a lot of value as well. So with that, Janice, I'll turn it back over to you. Thank you very much.